So when it comes to boron and pH studies, there's a really interesting correlation. So what I'm going to do first is I'm going to guide us through this figure here on the bottom left, right? And that's delta 11 boron mechanisms that reflect pH. So we find that when we have a seawater pH that is high, right, boron is in the form of borate, right? This means that 11 boron is forced to exist as borate. Corals therefore take on high 11 boron values, and then we find that there tends to be a higher delta 11 boron ratio, right? Whereas when we have lower pHs, right, boron then is in the form of boric acid. It prefers to be in boric acid, and it gets incorporated, into it. And then corals uptake lower 11 boron measurements. So what that means is that there's a pretty strong positive correlation between using pH and boron 11 isotopes to interpret what could have been a previous pH of ocean chemistry. And these are really important questions in trying to understand major Earth changes. Here's another graph on the upper left hand side that actually, it's the same kind of idea here, but just so you can see that pH is controlling the form that boron will exist in the waters, and then therefore also be incorporated into carbonate minerals. And then we're going to actually talk about this graph a little more during our case study, but I did want to show here that there is a nice strong correlation.